All right. Hi guys, so we're going to work on molality today. I just wanted to give you a more specific video on what I'm looking for and just provide kind of a refresher from yesterday. So, good to see you. Let's go to the whiteboard. Share. Okay, so molality, let's see if I can flip this without destroying everything. Okay. So molality, we're going to represent it with, a little m, which is different than this big M that we've been using to represent molarity. So this one we've seen before. This guy up here, this is our newer guy. Okay, so molality, you probably saw this yesterday. This is mol, if I could spell, that would be better. So this is moles of solute over kilograms of solvent. Now this is different than molarity, which is, the top part looks really similar. So this one is again moles of solute. This one, however, is over liters of solution. So the big thing that's different about these guys is this kilogram of solvent, this is specifically referring to exactly like what we're dissolving into. And then this one, this is referring to the combined volume of both the solute and the solvent. So that is how it's different. The other thing that's different between them, molality is temperature independent, whereas molarity is temperature dependent. What do I mean by that? So the density of something can change based on the temperature. And so what you can see here is at different temperatures, this volume might change. Because this volume might change, your molarity is going to change. Now that's a problem if you're trying to measure something specific. However, molality, mass isn't going to change based on your temperature. So molality is temperature independent. I think I spelled that wrong, but that's fine. All right, so molality is used a lot in colligative property calculations, which we're going to be doing tomorrow. So we're going to learn a lot about that tomorrow, but I just want you guys to get a little bit more practice with molality. So we're going to do one problem together, and then I'll have you keep practicing molality problems. So I would like you to do 10 molality problems. You'll have to upload your work. Yes, you do have to include work. But I just want to check in, make sure everything's going okay. Again, tomorrow we're going to do some colligative properties calculations. I will be uploading another video tomorrow. Yeah. All right, let's do a problem together. Clear all my drawings. Okay. Okay. So let's say that we have we have 30 grams of NaCl in, let's say 200 grams of water. Okay, so the way this is going to work molality is equal to moles solute over kilograms solvent. And it's kind of stupid, but the way I remember this, solute, well, it's not for solute. So solvent, when I was in high school, the way I would remember this, honestly, if you flip the V upside down, kind of looks like a wave, and water makes waves. That's how I used to remember it in high school. So if this guy is the water, this guy must be the thing that's dissolving. Okay, so I guess first things first, let's get this into moles. So we've got 30 grams of NaCl. Our molar mass, we're going to get from our periodic table. So I know Na is 22.99. I know Cl is 35.45. So about 23. So that's going to be about 57.44 grams per mole. Okay. So we're going to do our normal thing. 1 mole of NaCl is 57.44 grams. Super exciting. Let me get a calculator because I can't have you guys do that for me now. 30 divided by 57.44. All right, so we've got got 0.52 moles of NaCl. Okay, kilograms of solvent, so we have 200 grams. We know there are 1,000 grams in 1 kilogram. So we are looking at 0.2 kilograms. Okay, so we've got our moles, we've got our kilograms. Last step, put this over here. We've got 0.52 divided by 0.2. Molality equals that. And so that is, we've got a molality of 2.61. Okay. So again, I just want you to get a little bit more practice today. Tomorrow, we're going to do some other calculations with something called Van 't Hoff factors. So if you want to start looking ahead, I would look up Van 't Hoff factors. It's spelled like this. This kind of gets into the math of why a temperature will lower or raise based on what you add and how much it will lower and raise by. So it is kind of a fun thing to look at. But yeah, so we're going to do that tomorrow. That's about it for me though. So stop sharing. This is being silly. There we go. All right. Okay, I'm going to flip out of tablet mode because it doesn't want me recording. Yes, I would like to exit tablet mode. And that's about it. All right. Bye, guys. If you need anything, feel free to come on to Zoom. I'm setting up a chemistry time to meet every day at, I'm going to say 11. And if you can't make that, I'll have a physics time at noon every day. So it'll be a little bit more physicsy, but you can still come and ask your questions if you don't make the chem time. Bye.